in this problem, we're given that in triangle ABCD, M and N are 2 points on A, B, and CD, while E and F are 2 points on AD and BC respectively, such that EF is perpendicular to MN. Prove that EF is equal to MN. So to do this problem, first of all, we have to utilize the properties of the square and also the right angle here. Well, we realize that the intersection point of these are just in some random spot inside the square. And E and F right now, well, there's 4 random points on the sides of the square. So instead, in this problem, we can use translation to solve it. Notice that by property of the square, AD parallel to BC, AB parallel DC. So we can apply translation. So basically, we want to translate E and F such that E corresponds with A. And we call this point as X. And then translate MN such that M corresponds with B. Call this point as MY. So now what do we do? Well, we first translate EF to AX and MN to BY. After that, well, by properties of translation, we know that EF is parallel to AX and MN parallel to BY. Now, since EF is perpendicular to MN, we have AX is perpendicular to MN. Since MN parallel BY, so AX perpendicular BY. And then we also know that by translation, since AD parallel to BC, we also have, since AD is parallel to BC, EF parallel to AX. So we'll have the EF equals to AX. And similarly, we can say that we have MN equal to BY. I know that was a lot of helping lines constructed, but then with this out of the way, we know that AX is perpendicular to BY. So now we have formed a triple perpendicular congruence model, which states that since we have two right triangles, ABX and BCY here, where AX is perpendicular to BY, this forms a triple perpendicular congruence. Angle ABC and this angle are all right angles. So we can say that by triple perpendicular congruence model, TPCM, we have triangle ABX is congruent to triangle BCY. This can be proven through since we have an equal sign, we can prove there's two equal angles. So with that out of the way, we know that by congruence, AF equals to BY. So we'll have EF will equal to MN through the two equalities here. That is how you solve this problem.